Hello everyone, I am Brooks Hanley. I'm an application engineer here at Keysight Technologies. Today we're going to talk about the N5511A phase noise test system, also known as PNTS. What PNTS is, it's a phase noise measurement system, but it also measures AM noise and baseband noise. And phase noise is actually a large area in and of itself. Typically what we talk about is there's one port phase noise of things like oscillators or synthesizers. And there's also additive noise on something like an amplifier or a multiplier, divider, mixer, things like that. The flexible nature of the system allows us to measure all of those different types of noises. And so it's really a flexible noise measurement system is the way to really think about it. The real advantage of this system is we can actually measure down to the KT limits of physics. So let me show you a picture of our noise floor to show what that looks like. As you guys can see here, this is a 2-minute measurement at 7.2 gigahertz. And notice at the far out offsets, we've already hit the KT noise floors. KT in the phase noise world is minus 177 dBm per hertz in an absolute sense. And because it's a carrier to noise measurement, in this case, we have a plus 20 dBm input signal. So that gives us, plus 20 dBm carrier down to minus 177 dBm per hertz gives you minus 197 dBc per hertz. And some of you might be wondering why we're missing 3 dB there. Normally people think of KT as being minus 174 dBm per hertz. We remove 3 dB of AM noise in the measurement, and so all that's left over is the minus 177 dBm of phase noise. Here we have a mmWave measurement set up for PNTS. Internally, we can measure 40 gigahertz, but we have these baseband noise inputs that allows you to add external mixers to go up to whatever frequencies the mixers allow. In this case, we're measuring at 78 gigahertz. And so there's a lot of applications in automotive and satellite and other areas. So mmWave is really hot right now. We have this phase noise measurement interface, which is an accessory that includes phase shifters, couplers, power dividers, things like that. All those basically test setup accessories that you would have to have on your bench separately. We've put that in a box for you that has dampened, vibration dampened feet, and it's designed to minimize microphonics. The other thing that we have here is we have a stimulus source acting as so in this case, it's a PSG signal generator from Keysight. It could be really any signal generator. And then we split the signal. We go into, there's an LO path and an RF path, go into the 2 external mixers and into the baseband inputs into PNTS. As you can see, there's 2 inputs into the phase detector modules here. And so what that allows us to do is cross correlation. And so we can remove any of the noise, internal noise from the system and get down to that KT noise floor that I talked about earlier. As you can see here in this actual measurement at mmWave, we're measuring a ×6 multiplier. It's an active multiplier because there's a 1/f noise curve at the closer in offsets. And then we hit a floor out at around 3 megahertz offset at minus 155 dBc per hertz. For further information, visit keysight.com. Thank you.